Sorry. Yeah, I kind of went with a slightly techy topic. Couple of disclaimers. One, I assume we have pizza, so some comments might be inapplicable. And two, PowerPoint is being a bitch, so the movie isn't playing. I just got some frames, so let's make do with what we have. Yeah. Okay, so I'm going to start with what happened. Initially, we had like sound energy running around, we had radio, blah, blah, blah. Then we had digitization where we are right now, pictures and sound running out together. But you know what? I kind of like teleporting stuff around. So there's a way to make this possible, and that's what I want to talk about. How do we do it? Well, basically, we're going to take help from Mother Nature again. We're going to mimic it as well as possible. We're just going to make really tiny atoms which mimic the human body or something close to that. But right now, we're just going to start with inanimate objects. We don't want people squelched. So how do we do it? Think about making like really small robots which would align themselves to mimic the texture and color of something that we want to teleport. Send this information across and the robots align on the other side, and you have something that was here there. So it's something like programmable clay, yeah? We don't really want to go into a wormhole and come out the other side. What we want to do is something like 3D faxing. We're going to send 3D information on a wire. So this is what Claytronix is about. You need smart software, some good compression, and you got it. So how do we do it? Something like this. In the future, we'd have stuff that just pretty much rises out of clay, like this, and it would be, we can actually shape and mold it with our hands into some cool shapes, and this is going to affect our life in a big way. So let's just have a look at what is Claytronix. It's an abstract future concept. If you have nanoscale robotics and computer science together, you have like awesome computational power. So these are the baby robots, and these are going to work wonders to actually produce on a large scale teleportation and 3D faxing. So how exactly do we do it? These baby computers, they're called CATMs, or Claytronic atoms. They interact with each other in a way such that like it mimics the user's motions, like the hand motions as you move it. These atoms align themselves, so it's clayish, I guess. Yeah. So yeah, the CATM is the building block of this thing. So that's a CATM as of the moment. This is 44 millimeters in diameter, but we're going to push like nanometer scale very soon. So it has a CPU, a pixel on top to display some information, etc. And it also has transmission wires, but I'll be coming to that soon. So yes, it's got 24 electromagnets, stuff like that, lying around the sides. And these electromagnets turn themselves on and off to actually make the CATM move. This is like, 3 CATMs moving. You can see that, like, back. It's actually a video game. It sounds nice. So yeah, 24 magnets. You think it's going to fail, right? No, it's not. It's like really small magnets, and they got almost nanowatts, attowatts apart to actually make them move. And the power is actually transmitted wirelessly through magnetic resonance coupling. You don't need a wire to transmit power. You can transmit power across the earth. Yeah, there is a lot of fancy terms here, and I can't, quite qualify most of them. But yeah, think of it something like we'd be radiating it with power, and the CATMs would draw from this power to actually align and shape themselves into the matter that we want it to be. So what exactly does a CATM do? It gets the power, it localizes, which means that it has to establish where it is in the network. And then finally it has to get to work. That is, it has to move to where it wants to be. So if it's here, it's got to go there, it's like, and it goes like this, right? So, and what sort of latency would you have? Like 100 milliseconds at the moment, but you'll get like way better. So what we do is on this side, we ask the CATMs to establish their location, and the whole thing is compressed, wired over wirelessly, and on the other side, the CATMs just mimic the entire thing. So it's like that shape is transmitted to this side, basically by just spatial orientation, I guess. So yeah, also as far as shaping goes, we're gonna have some hand sensors and stuff. So the clay thing would actually work like the pressure sensors would help the CATM align itself, etc. as we shape it. So the beauty is that when two atoms are together, they're magic, but alone they do shit. So how do we tell it stuff, right? So obviously the power lies in software again. Think about it, we have like about 1 billion atoms. Atoms are really small. We have like 1 billion parallel processors. That's more than anything we have like at the moment. I think that can beat the shit out of every supercomputer here. So we just need smart software, and yeah, the electronics as usual stand up. I'm an electronics graduate, so I'm very proud. So with some good algos and this sort of computational power, we can actually achieve 3D faxing and teleportation. Think about what you can do with this. You can work from home, you can work from outer space, you can have virtual meetings, you'll have 3D TV, you'll have football basically playing in front of you, you'll have virtual anything basically. You know, you're just limited by your own imagination as to what you can actually do with it. Come on, it's like the ultimate dream of mankind, right? Yeah, I know we all want it, but we're not going to get it. It's a Carnegie project in development.
Whoa.
As of the moment, it's a 44mm technology, but there is like talk about electrostatic atoms, etc., which are closing in on the real deals. So in some time, we're going to see it. Yes, so be patient. The time will come, and when we'll have 3D faxing and teleportation. So that's what.